Hi everyone, welcome back to chemistry. In this video, we're going to talk about how we use significant figures in calculations. So we're going to take a bunch of measurements and then we get our significant figures. And then what if we have to do calculations with those sig figs or those measured values? How do we still accurately show how certain we are in our calculations or in our numbers? So for multiplication and division of measured numbers, remember that anytime we're talking about sig figs, we're talking about measured numbers rather than exact. So when we're talking about multiplication and division, the final answer is always written so that it has the same number of sig figs as the measurement with the fewest sig figs. So that sounds confusing. Let's break it down. So for example 1, it says multiply the following measured numbers. So we have 24.66 centimeters times 0.35 centimeters. Okay, so when you multiply these numbers, first off, what I like to do is say, I first like to determine how many sig figs each of those numbers has. So how many sig figs are in this number? Pause the video, try it out. Yeah, there are 4 sig figs in this number. What about the next one, 0.35? How many sig figs? Yeah, there's 2 sig figs there. Remember, this leading 0 is not a sig fig. Okay, so if there are 4 sig figs and multiplied by 2 sig figs, well, first off, which one of these numbers is more certain? The one with 4 sig figs is more certain. Okay, so we always want to report the least certain number, right? Because this is kind of what is limiting our calculation. We can't say we are certain of the final answer to 4 sig figs because we're limited by this number that we only have 2 sig figs. So our certainty is lower in that number and we need to reflect that. So we reflect the lowest certainty rather than the highest. Okay, so when we're multiplying, your final answer needs to have the same number of sig figs as your lowest number of sig figs. And that's why, even though our calculator displays 4 numbers, so we plug this into a calculator and this is what we get, we have to round it until we get 2 sig figs. Okay, so the way that we do that, if you want a little review of rounding, is anytime you're trying to, we know we want to round to 2 sig figs, so this would be the spot that we need to round to. So then you're going to look at the next door neighbor and you're going to say, is that neighbor next door, is it lower than 5 or above 5? And if it's lower than 5, lower than 5 or 5 and above, I should say. So if it's 5 or above, you round up. If it's 5 or if it's below 5, you round down. Okay, and since this number 3 is below 5, we leave this number alone, and we get 8.6 centimeters squared as our final answer. And that way, the final number that we report still has 2 sig figs. Okay, so, oh, I like the way they say that too. Multiplying 4 sig figs by 2 sig figs gives us an answer with 2 sig figs. Take the lowest number. So that's when you're multiplying or dividing. Okay, the rules are different for adding and subtracting. Okay, so let's do another example. So the first thing you want to do anytime you get an equation is I always make sure that I count the number of sig figs. So for this first one here, how many sig figs are in that number? Oh, sorry. How many sig figs are in there? 3. Yeah, 3 sig figs. What about the next number, 0.30? Yeah, there's 2 sig figs there. And then what about the number on the bottom? Yep, 3 sig figs. Okay, so what is the number that is limiting our number of sig figs? What's the lowest number of sig figs we have? This one here, right? Okay, so now what we're going to do is you're going to just carry out the calculation, get your answer, and then you can round that final answer to 2 sig figs. If you start rounding these before you've actually carried out the calculation, you're going to start getting a less accurate number, because every time you round numbers, you're getting less and less accurate, right? So carry out the entire calculation first, right? This number times this number divided by this number, and then round at the very end to 2 sig figs. Okay, so using our calculator, we would type in 21.5 multiplied by 0.30, and then we divide by 1.88, and the number that comes out on the calculator is this long guy right here. So once we have our calculator display, then it's just a matter of finding out how many sig figs we need to round to. So if we want 2 sig figs in our final answer, because that's the lowest amount of sig figs we have, and we are multiplying and dividing, we want to round to this digit here, because that's going to give us 2 sig figs. So we look next door. That one is the number 3, which is lower than 5, so we leave the number as 3.4, and that's our final answer. And then you always have your units there. Okay, and I would just double check. We got 2 sig figs at the end. 2 sig figs is our lowest number of sig figs. So adding significant zeros. This is just kind of like a side note. So when you're using your calculator to do these, your display might contain fewer sig figs than you need. And that's just because your calculator display doesn't always show these zeros, right? Sometimes your calculator is actually just going to make this 6.0 and maybe 2.0, right? It doesn't know that this 0 in this spot here is actually important to us, right? Because you could keep writing this out forever. So in the calculator's eyes, sometimes they will leave off some of those sig figs. We don't want to leave off any sig figs because we want to show how accurate our numbers are. So when you're using a calculator, you have 2 sig figs here and 3 sig figs here, and you get 3 here. You're going to have to add in the zeros until you get the sig figs that you started with, or the sig figs that you should be in your calculated answer, I should say. So it showed us 3, and we want to add, let's see, because we are multiplying or dividing, we know that we need to have the lowest number of sig figs reflected in our answer. So the top part has 2 sig figs, and the denominator has 3 sig figs. So this is the one that we're going to have 2 sig figs in our answer. So if the calculator displays 3, we're going to have to put a 0 there so that we show that we have 2 sig figs. You wouldn't put just 30, right? You're going to have to add that decimal point in there because that's now a different number. 30 is very different than 3, okay? So we have to add in that decimal point. And that's okay because when you count these digits, you're still going to have 2 sig figs. So you're not making anything up there. All right. I guess I should leave that on there. Yeah. Okay. Let's do a learning check for multiplying and dividing. So pause the video, try it out, and then you can go ahead and watch it. Okay. So how many sig figs, that's my first step, is... Actually, let's analyze the problem first. So we know that we're given just multiplication and division. So we know... Oh, no. Oh, my gosh. Sorry, you guys. Okay, so we know we have just multiplication and division, so we can just, in our final answer, we just need to report the lowest number of sig figs that we have in our measured values. So we have 3 sig figs here, 4 sig figs here. And how many here? Yeah, 2 sig figs. Okay, so this one is the lowest number of sig figs. So how many sig figs should my final answer have? Yeah, that's right, 2. Okay, so let's go ahead and do this calculation. So we got 5 times 3.408. That gives me 17.04 divided by 2. I'm just breaking it up into 2 steps. You don't have to do that. You can do it all on your calculator. Okay, so then let's divide by 2, and we get final answer of 8.52. 8.52 what? Centimeters. All right, so let's see. How many sig figs do we need in our final answer? 2. So where do we need to round to? Which digit? This one. Yeah, so since 2 is lower than 5, I'm going to round to 8.5 centimeters. Notice that your final answer is still very close to the answer that you get on the calculator. It's just reporting the correct number of sig figs. Okay, so let's double check our work. Hopefully I got that right. And I did. Okay, adding and subtracting is different. And some people find it a little bit more difficult than multiplying and dividing. So for addition and subtraction, the rule is that your final answer has to be written so that it has the same number of decimal places as the measurement with the fewest decimal places. So for multiplying and dividing, we're looking at sig figs. So we're counting our sig figs and we're determining, hey, which number is, how many are my fewest sig figs? And then my final answer needs to reflect that lowest number of sig figs. Adding and subtracting, we actually look at the fewest decimal places. So which number has the fewest decimal places? And then that's what your answer has to be rounded to, is that decimal place. So, and the reason for that is that numbers with fewer decimal places are actually less accurate. And I want you to think about the ruler example from one of the previous videos. Remember when I was measuring the ruler, or measuring the block of wood with the ruler, I measured between 4 and 5, and I got like 4.5. And this was my estimated number. Well, then I had another example where we got to 4.55. And the reason we got to this estimated number is because we actually had more tick marks for this value, for that ruler. And so this number is actually more accurate than this one because it has more decimal places. I got further out. I know at least 4.5, and then another number is my estimate. Whereas this, I only know 4, and then I estimate that last one. So fewer decimal places means less certain number. Okay, so for adding and subtraction, we're looking at decimal places. So the previous professor who used these slides already kind of did the work for us. So the lowest decimal place that we have is the tenths place. These other measurements go out further. This one goes to the hundredths place, and this one goes to the thousandths place. Okay, if you need a refresher on the place values, go watch the math review. I think it's in the first math review video. So we need our final answer to be reported to the tenths place because that's the lowest decimal place. So when we add these numbers together, 2.012, 61.09, and 3.0, we have to, we put them in our calculator and then we round our final display so that we're in the tenths place. Okay, so we got 66.102 for our calculation, and then we wanted to get just to the tenths place. So we look next door to the 0 and we say, okay, that's less than 5, so I'm just going to leave it at 66.1. Okay. So let's go ahead and try this example. So let's do it over here. We got 65.09 minus 3.0. And if you were doing this on your own and this wasn't set up for you yet, so say it was written like this, remember that you want to line up the decimal places. That's going to make your life easier. Okay. So I put them in a line like that. All right, so we're subtracting those two things, and I know when I'm looking at this that this has the lowest decimal point because it's in the tenths place. The other one is in the hundredths. So let's just write a little line down here, and our final answer needs to be reported to that line. So when we put it in the calculator, apparently we get 62.09. Oh, let me make it so we can see that. 62.09, we need to round to this decimal place. So now we have a next door neighbor that is larger than 5. So we need to round this guy up. So that's 62.1. Sorry, let me scooch that over a little bit. 62.1, so that it's in line. And now we have our final answer, which is rounded to the tenths place. Okay. All right, try this learning check out on your own, and then we will check back in. All right, so what they did was they lined up their decimal places, their decimal points. And then let's go ahead and draw which one is the one with the lowest decimal place. That's this one here. So now we're going to go draw our line through here. And they rounded to that decimal place after they did the calculation. Again, you don't want to round right here. You don't want to round in that step because then your answer on the calculator is going to be further from the actual value. So don't round too early. Always just round at the very end of your measurements. Okay, so that's for adding and subtracting, and then we also did multiplying and dividing. We will have multi-step calculations where we will multiply and divide and add and subtract, but we'll save those for the future. So I'll see you then, and have a great rest of your day.